Welcome. In this video, we will give an introduction to data visualization, turning data into clear, actionable insight. We will introduce data visualization through 3 videos: how we'll match data types to effective plots, learning how to interpret and critique visualizations, and review popular plotting libraries such as Matplotlib, Seaborn, and Plotly. There are 4 types of data: nominal, ordinal, interval, and ratio, each differing in ordering and numeric meaning. For example, categorical data can be divided into nominal and ordinal. Nominal data has no order. For example, pets is a nominal data type. On the other hand, movie ratings is an ordinal data type where we can compare them. From numerical data, ratio data must make sense if you divide 2 data points. Say, for example, 20,000 divided by 1,000 gives 2, a ratio that makes sense. On the other hand, 20,000 divided by -1,000 gives -2, which does not make much sense, therefore likely interval data. Now pause the video and do this as an exercise. Label each of these as one or more of the 4 categories. Now let's talk about visualization types. Rather than picking charts by the message they emphasize, choose them by the data's type and dimensionality. For one-dimensional data, use bar, horizontal bar, pie charts, or histograms. For 2-dimensional relationships, use scatter plots, line plots, box and whisker charts, or heat maps. For 3 or more variables, consider scatter matrix views or bubble charts that encode extra dimensions with size or color. Bar charts are ideal for one-dimensional categorical data, particularly nominal and ordinal variables. Each bar shares a common baseline, has equal width, and its height represents the value or count. Bars may be drawn vertically or horizontally, and colors or patterns help distinguish groups. Use bar charts when you need a simple, direct comparison of categories at a glance. A scatter plot maps 2 numeric dimensions, usually interval or ratio, onto the horizontal and vertical axes, with each point representing one observation. Look for direction and strength of association, clusters, nonlinearity, and outliers. Categorical variables don't serve as axes but can be added with color or marker shape to provide context, helping you decide next analysis steps. Let's talk about some plotting scenarios. Household labels are nominal categories, while dogs, cats, and rabbits are quantitative counts, ratio scale. To compare species across household types, use a grouped bar chart. Side-by-side bars per household. Use stacked bars if you want each household's total pets. For midterm versus final, collect paired numeric scores and plot a scatter plot with a fitted line and compute the correlation or regression to assess how well midterm predicts final. Pie charts are popular ways of visualizing categorical data. Pie charts show how a whole is divided into category proportions. They are best for nominal data. Each slice represents a category's share. You can use them for ordinal data, but they do not convey order well. They are not appropriate for raw interval or ratio values unless those values are grouped into categories. Keep slices few, label percentages, and use clear colors for readability. We all know histograms. Histograms summarize the distribution of continuous data, typically interval or ratio measurements, by grouping values into adjacent bins. Key choices are the range, number of bins, class intervals, and bar width. The bar height shows frequency or density. Read a histogram for center, spread, skew, modality, and outliers. For example, this plot clearly shows 2 peaks, a bimodal distribution. Heat maps are a great way to visualize, for example, New York City crime data by region. Heat maps encode the density or intensity of 2 numeric dimensions, dim1 and dim2, using color. Brighter colors indicate higher counts or larger values on the color bar. They're ideal for bivariate continuous data, typically interval or ratio level, or for spatial intensity. Now to comparing across multiple groups. A box and whisker plot summarizes a numeric distribution using 5 values: minimum, first quartile, median, third quartile, and maximum. The box shows the interquartile range, the orange line marks the median, whiskers extend to the non-outlier extremes, and circles mark outliers. Comparing the dog, cat, and rabbit boxes makes differences in median, spread, skew, and outliers easy to see, and box plots work well for interval or ratio measurements like weight. Another plot. Violin plots combine a box plot with a kernel density estimate to show a numeric distribution for each category. The width of each violin reflects density, while an internal bar often marks the median and quartiles. Use them to compare shape, spread, and multimodality across groups, especially when sample sizes differ. Typical setup: categorical variable on the x-axis and interval or ratio measurements on the y-axis. Line plots are a great way to see trends like stock data along a timeline. Line plots connect data points with straight segments to show how one numeric variable changes with another, usually over time. They suit interval or ratio data and highlight trends, peaks, and short-term fluctuations. Think stock prices or sensor readings. Use a line plot when the x-axis is ordered and you want to emphasize continuity instead of isolated points. This one is really cool. Bubble plots map three variables: the x position, cat, dog, rabbit; the y position, house, apartment; and bubble area indicating magnitude, for example, household counts. Three-dimensional scatter plots map three numeric variables onto x, y, and z axes and can reveal multi-way structure. But a static 3D view is often confusing. Depth and occlusion hide points. Only use 3D when viewers can rotate, zoom, or filter interactively. For static reports, prefer a 2D scatter with point color or size, or small multiples to show the third dimension. A scatter plot matrix shows all pairwise 2D plots for three or more numeric variables, letting you inspect relationships across dimensions. The diagonal typically shows each variable's marginal distribution as a histogram, while the off-diagonal panels reveal correlations, nonlinear patterns, clusters, and outliers. It's ideal for interval or ratio data during exploratory analysis and works best with interactive controls when the dataset is large or dense. Color encodes the third variable or class. Two overlapping clusters reveal different three-dimensional relationships. Rotation or interaction is needed to judge depth and correlation. So that was a quick intro to data types and how we choose different plots to visualize them. Next, we will discuss interpretations of visualizations.